In this example, it says for a certain strain of bacteria, R is 0.872 when T is measured in days. So how long will it take for 9 bacteria to increase to 730 bacteria? All right, so notice our rate here, our constant, it is a positive number. Whenever the rate is greater than 0, it models a growth. So currently the bacteria count is at 9, and then it's asking how long will it take for the bacteria count to reach 738. So we're going to go ahead and plug in the values we know so that we can determine the exact amount of time it will take for that type of growth. So here the amount is, this is the future amount. Remember, A is the future amount. So that's going to be the 738. So how long did it take to get to there? So that, remove the A, replace it with 738. P is the initial amount, the amount it is at the very beginning, and we were given that that's 9. So remove the P and replace it with 9. We were given a rate of 0.872. Remove R and replace with 0.872. The time, we don't know how long it takes. That's what we want to find out. So we're going to leave T as is because that's the variable we want to solve for. So once we plug everything in, it's going to look like so. And now to solve this exponential equation, what do you think we have to do first? Okay, so step 1 is we want to isolate the base E, the number E, we want to isolate it, get it all by itself. So what step are we going to have to take to begin that process? If you said divide by 9, that is correct, because notice it's kind of sandwiched. E is sandwiched with the 9. They're stuck together, joined together, which means that they're being multiplied. The opposite of multiplication is division. What do you divide by? You always divide by what you want to get rid of. So since we want to get rid of the 9, we divide by 9. And you know what the rules of equation says. Whatever you do to one side, you must do to the other. So once we cancel those common factors of those 9 on top and bottom over to the right, what we're going to be left with, and by the way, 738 divided by 9 equals 82. On the right side, we have E raised to the 0.872t. What's our next step here? We want to get rid of the E. How do we get rid of the E? I'll give you a hint. Think of opposite operations to solve. Okay, so what will cancel that out is the natural log. So what we're going to have to do is take the natural log of each side, ln of each side. Okay, and now anytime that ln and e are together like that, being multiplied, they cancel each other out. And so what you're going to be left with on the right side is simply 0.872t. One last step and we will have solved for t. What do we need to do? Again, these two terms are being multiplied, 0.872 and t, because they're joined together. The way we solve is we do the opposite. The opposite of multiplication is division. Divide by what? Well, you want to divide by what you want to get rid of. We want to get rid of the 0.872 and get t by itself. So we have to divide both sides by 0.872. Whatever you do to one side, you must do to the other. And what we have is the natural log of 82 divided by 0.872. And if you calculate that on your calculator, what you're going to get is an approximate decimal of 5.05, which means that it will take only 5 days for the bacteria to reach that level.